Okay, regression comes with some assumptions that you need to be aware of because you need to make sure that your data um, meet those assumptions, and therefore that regression will give you accurate conclusions about your data. And one of the big assumptions in regression is that there aren't any unusual outliers in the data set. That the relationship you see when you run a regression is not due mostly or substantially to just a couple of what we call outliers. So let's have a look at what an outlier might look like. Here is the scatter plot you've already seen of the relationship in the data set between the number of hours an individual spends watching television and the percentage of body fat. Okay, notice how all of the points kind of conform to the same pattern, and we have this 0.55, almost 0.56, 56% R-square value. Watch what happens if we introduce a half a dozen outliers into the data set. What I've done here is I've added 6 cases at the end that kind of reverse the typical pattern. You have, let's see what we have here. We have weekly hours and percentage body fat. So you have somebody watching a lot of TV, but they don't really have a very high percentage of body fat. And then here's somebody who watches very little TV, but has a pretty high percentage of body fat, and so forth. So if we add those 6 outliers, look what happens to the line. Remember how steeply it was slanted here? But when you add the outliers in, remember the line, the trend line represents all of the points, including outliers. So what happens is we've got this little group of outliers up here, individuals who don't watch a lot of television but still have fairly high percentages of body fat. And then we have this little group down here, individuals who watch a lot of TV but have very low percentages of body fat. And this is not an unrealistic kind of thing. There are lots of things go into percentage of body fat, not just watching television. So it's quite possible that that for some other factor, an individual could be unusual on our typical compared to our typical pattern here. But what happens is when you have these extreme or unusual cases in here, they tend to flatten out the line, okay, and they also reduce the R-square figure. If these had been the data coming out of our experiment, we would conclude that we can explain less than 1% of the variation in body fat based on how often somebody watches television. When in fact, what we really have are 3 different kinds of populations here. You've got this small group up here who have sort of one thing going on. You've got this kind of typical group here in the middle, in which we already know based on this plot that there is a relationship between hours spent watching TV and percentage body fat. And then you've got this third population down here who watches a lot of television, but apparently they don't have very high body fat percentages. So you have to watch out for these, because if you don't know they exist and you look just at the Pearson's R or the R-square, you could end up making erroneous conclusions about your data set. Now one of the easy ways to check for these outliers is to produce this kind of a chart here, and that can be done easily enough. But it's even easier when you're setting up your regression analysis to check that residuals plot box that I showed you how to check in the last video. When you do that, you're going to get something like this in your output. Back in the original output, it was over here to the right. If you scroll out a little bit, you'll see it right there. And notice what you have here is you have a line here at 0, okay? That represents, if a point is at 0, like this one right here, it means that it fell exactly on the trend line. That black line there, okay? That means the point fell exactly on that line. Okay, whoops, wrong place. And so the farther away from that 0 line a given point is, the less like the trend line it is. Okay, the farther away from the trend line it is. And what you're looking for when you look at a plot like this is one or more points that are kind of all by themselves. They're far away from that 0 line there. and they're sort of by themselves. For example, if you look at the same sort of plot for the outlier data I just showed you, notice how you've got this little group up here and this little group down here. They're far away from the zero line, and they're also kind of by themselves. Notice how they correspond to, well, to be precise, this group here corresponds to this group right here, and this group here, okay, corresponds to this group up here. So it's just a quick and easy way to kind of spot those outliers. And if you see that going on in your data, then that means you kind of need to stop and take a closer look at your data, perhaps by generating a scatter plot like this, identifying those outlier cases and deciding what to do with them. Okay, so but assuming that things look a little more like this, when you look at that residual plot, you're in pretty good shape, and you can go ahead and interpret your R-square and your other output accordingly. Okay, so that's a quick word about outliers and their influence, and how to watch for them when you're running a regression analysis.